Hello everyone, I'm Amulya Biyar from Sri Venkateshwara College of Engineering and I belong to the branch CSE AI. So today I'm back with another video on the subject Automata Theory and Compiler Design and on the topic an undecidable problem, that is regular expression. So now let us look into the contents of what we're going to learn today. That is, Introduction to Undecidable Problems, Definition of Regular Expressions, Overview of Regular Expression Matching, Undecidable Problems in Regular Expression, Proof of Undecidability using the halting problem, Examples of undecidable regular expressions, Implications and limitations of undecidable regular expressions, the approaches to mitigate the undecidability, and the conclusion. So now let us see the introduction to undecidable problems. So the undecidable problems are computational problems for which there are no algorithm that will guarantee a correct solution for all possible inputs that is given. So in other words, there is no general procedure that can determine whether the given instance of problem has a solution or not. So this is called undecidable problems. So this concept is fundamental result in the theory of computation and stems from the work of mathematicians and logicians. Now let us see the definitions of regular expression. A regular expression is a sequence of characters which will define a search pattern. So it is a powerful and concise way to describe a set of strings, allowing for complex text matching and manipulation. Regular expressions are widely used in various programming languages and applications for various tasks such as pattern matching, text validation, and text extraction. So they are employed in programming languages like Python, JavaScript, Java, and others in tools like AWK and text processing and text manipulation. So the metachars and quantifiers. So these meta characters will include the symbols like star, plus, which will enable the pattern matching with varying degrees of specificity and complexity. And the text manipulation includes the allowing of identification and extraction of substrings from the given language. Now let us see the overview of regular expression matching. The regular expression matching will involve using a regular expression to find patterns within a text or set of strings. The process typically includes searching, validating, or extracting information based on defined pattern. So the pattern matching process will include this engine process the text from left to right, attempting to match this specified pattern. So the regular expression matching is widely used for tasks like pattern searching and text extraction and string manipulation in programming languages, text editors, and command line tools. So the performance considerations are crucial for maintaining optimal performance in applications. So they are made use the regular expressions in software. So for input validation and many other processes. So now let us look into the explanation of undecidable problem in regular expression. So the undecidability problem in context of regular expression is related to the question of determining whether a given expression will match all possible given inputs. So here we have the undecidable problem as the nature of ambiguity. So the quantifiers such as the star or the plus symbol will introduce ambiguity when deciding how many occurrences of a character or group should be considered in the match. So next is the language acceptance as a problem. So the language the challenge is determining whether a given expression will accept all possible strings in a defined language within a specific conditions. So these are some of the problems in determining the regular expressions. Now in this slide, let us see what the halting problem is and the proof of halting problem in undecidability. So basically halting problem is nothing but In a given arbitrary program and input, we should determine whether the program will eventually halt or return forever. So this is a halting problem, and the undecidability of this problem can be demonstrated through reduction from halting problem. If we had a decision algorithm for regular expression undecidability problem, we could construct a algorithm to solve a halting problem which is known to be undecidable. And then the algorithmic limitations. So the concept of halting problem highlights the inherent limitations in developing algorithms that can solve the decision problems. So now let us consider some of the examples of undecidable regular expressions. So here the recursive definitions within regular expressions will often lead to undecidable scenarios. For example, now let us consider this expression here. So in this expression, to define a language where strings will start with A, which is followed by a balanced number of B's and C's. So here the number of B's and ending with D or E. This pattern will include a form of recursion with back references. So this is undecidable. And then the unbounded quantifiers. So the use of star or plus symbols will determine the presence of ambiguity there, which particularly when dealing with strings of varying length and complexities. Now let us look into the limitations of undecidable regular expressions, that is the computational complexity. So the computational complexity of regular expressions and the algorithmic uncertainty is associated with certain tasks which will involve regular expressions are essential considerations in analysis and practical usage of these patterns. So here we have computational complexity. So here compiling a regular expression into finite automation or another internal representation will introduce a one-time computational cost. So the compilation complexity will depend on the features of the regular expression, and it may range from linear to exponential in some of the cases. So and then we have the algorithmic uncertainty. The presence of unambiguous constructs or unbounded quantities can introduce uncertainty in the behavior of regular expression. The order of backtracking and choice of alternatives will also affect the overall efficiency of the matching. Now let us see how to mitigate or overcome the undecidability in regular expressions. So we have some of the methods or safety precautions here, or any of the methods that we can follow. So the first one is restrictions of features. So this will reduce the expressive power or regular expressions, but it will enhance the predictability. And then we can also have the careful design and testing. So by understanding the regular language that is defined by expression, ambiguity can be minimized. And then we can also make use of specialized languages. So these may provide additional features or constraints that can make certain properties decidable. So next we can also make explicit quantifiers. So instead of using unbounded quantifiers like star or plus symbols, using explicit quantifiers will define bounds. So these are some of the approaches with which we can mitigate undecidability in regular expressions. Now let us see the future advancements and the conclusion. So first one is scalability imperatives. By addressing the scalability imperatives in regular expressions to evolve the complexity of modern data and computational tasks, so we can accommodate it. And then the interdisciplinary collaborations. So by increasing the interdisciplinary collaborations from logical, mathematical and computer science, we can develop solutions for undecidable problems in regular expressions. And then by using the emerging technologies such as neural networks or quantum computing, we can revolutionize the decision making in undecidable problems. Now, I thank each and everyone for watching the video completely till the end. I request you to please like the video and share the video amongst your friends. I also make sure to come back with another video on different subject. Until then, have a good time. Thank you.